Okay, and now we're going to start the slideshow up. Let's see wherever from the beginning. Oh, there it is. This is great. Okay. Let's check the time. We got 2 minutes. So hold on about 2 minutes and we'll start up, okay?
Awesome.
Thank you. All right. Okay, Glenda, you ready?
Sure am.
Okay, we're going to start. Hi there. My name is Rob Canzaneri, and I am the leader of the Data Architecture Virtual Chapter for SQL Pass. And today we're going to have a presentation from Glenda on what is the point of data warehousing. We're always looking for speakers, so if you'd like to speak for our group, please email us at davc@sqlpass.org. And today we have Glenda coming in, and she is the chapter leader of a new user group called the Acadiana SQL Server User Group. And you can go visit their website at www.acadiansql.org, and their next meeting will be May the 27th. And if you're in Lafayette, Louisiana, or you're somewhere in Louisiana, feel free to come. Come check out this great new chapter. I was there last month and had a great time speaking. So we're going to go through.
Wonderfully.
Oh, thank you. All right. So one cool thing about SQL Server Saturdays, they're everywhere, and there's always going to be an event somewhere.
Hey, Rob.
Yes.
Your slides aren't showing if you're trying to show slides.
Oh, they're not showing? Oh, okay.
No.
Let me go back a screen. Hold on. Thank you. Are they coming up now?
Yes.
Great. I apologize. All right. So let's go back a screen. So here is the link for the, my email address, and here is the link for the acadianasqlserver.org website, and Glenda's, the chapter leader again, and next meeting will be on May the 27th. So we'll go to the next screen here, and here are some upcoming SQL Saturday events. There's going to be several, like in Houston, Jacksonville, Detroit. So if you want to register, just visit the website, sqlsaturday.com, and sign up. Houston one's coming up. That sounds interesting. I might attend that. They're all over the world. You can see Puerto Rico, Costa Rica, etc. We have a lot of virtual chapters, and feel free to get more involved and check out other virtual chapters. And you just sign up at the sqlpass.org, and you can attend the ones that interest you. And the last thing I want to say is SQL Pass is always looking for people to volunteer or get involved. And if you want to get involved, visit the website, and there's a lot of opportunities. So with that, I want to thank Glenda for coming today and hosting, giving this great presentation. I actually had the opportunity to meet Glenda at our Baton Rouge chapter, and then I got the opportunity to speak at her brand new, SQL Server user group. Yeah, thank you. And I had the best time. I really did. We got to meet a lot of people, and I can't encourage everyone to come out to this user group. It was great. And we got to eat some great food. I mean, I had shrimp pizza. I don't think I've ever eaten shrimp on pizza before, and it was just phenomenal. So,
We definitely know how to eat down here.
so they had some great food. So with that, I'm gonna go ahead and switch the screen over there to Glenda. So Glenda, let's see if this works. So here we go. Let's see. I got your screen. That's great.
All right, wonderful.
So I'm gonna let you speak, and if y'all have questions, we'll hold off, and we can ask Glenda when she has a breaking point. Thank you.
Great, thank you. All right, it is a pleasure to be here. Thank you very much for having me. And we are going to be talking about data warehouses today. My contact information is here for you. Again, my name is Glenda Gable. You can email me. I also have a blog. I also have my LinkedIn here. And like he said, I am the president and co-founder of the Acadiana SQL in Lafayette. And you can reach us at acadianasql.org. All right, we're going to kind of jump right into it. So we're going to be talking about what the point of a data warehouse is. We're going to compare the online transactional processing databases versus the analytical databases. Talk about the benefits of a data warehouse. And then, because it's very important to get your data out, we're also going to talk about indexes. So what is an index, what the ultimate goal is. And we're going to talk about the different types of tables in a warehouse and how you would index those as well. How to find out which indexes you should have, and then kind of go over some few tips after that. So grab your coffee, sit back, and let's go. First of all, what is the point of a data warehouse? Well, these are just a bullet points of several topics, but really you have a single repository from all kinds of different sources. So Excel, Oracle, XML files, CSV files, other SQL databases, things like that. Your data can be consistent across all of those sources. So the formatting of your data, you can actually have all capital case or camel case, things like that. And from a user's perspective, they have really no clue, and they don't need to know which source system this record came from or that record came from, because it all looks the same for their reporting analysis needs. You can also map a lot of values to a common value. So let's say that you actually have you order black pens from Office Depot. Well, they're going to have a different product number or SKU than the Walmart black pens, even though they're the same product. You can actually have your company's unique ID for that, and you can map all of that in the ETL process so that you actually have one value for common across different sources. The quality of your data. Throughout the ETL process, you really can clean your data for common data entry errors, such as maybe you provide licenses for, I don't know, construction or pharmacy, things like that, and everything's for a year. Well, if someone doesn't actually key in a date at the end of the year, you can fill it in throughout the ETL process. So that way your reporting and analysis is still very consistent. It also can kind of filter out records that are in the source systems but shouldn't be reported on. Performance. Most transactional and warehouse hardware, they're spec'd differently. They have different needs. So a transactional system may need more I/O for writing, whereas the warehouse, you may have it set up to use more memory to hold data. It's very, very dependent on your environment and what you need, but for the most part, you're going to have different hardware needs. Controlled data security. If you give access to someone in the data warehouse to run reports off of and things like that, they don't necessarily need access in the source system anymore. Archiving. If your company wants to archive older data from your transactional systems to kind of help with performance and things like that, well, your data warehouse can be used to keep those records available for reporting and analysis. It can also be used, if you want, to keep a copy of each record and how it changed. So if you have an order and the shipping address changed, you can actually keep a record of all of those changes that happen and when they happen and by whom. This is really just a sample grid, a simple grid, sorry, of some comparisons between a transactional database and an analytical one. In transactional, you're going to have current data. Analytical, you'll have current and historical. In a transactional database, you'll have simple known queries. Your programmers have stored procedures or views or code within your software, and you know how that software is going to interact with the database. Whereas analytical, you're going to have complex, aggregate, or ad hoc queries. User's mind always changes, so it always gets different. In a transactional system, you're going to have smaller record sets with shorter transactions. Analytical, you're going to have large record sets and longer transactions. In transactional, you are going to be doing a lot of inserting, updating, selecting, things like that. You're manipulating the data. Whereas in analytical, you're really just reading the data. You just want to see it. In a transactional, you're doing real-time updates to current data. In analytical, you're doing batch updates. Even if that batch process runs multiple times during the day, you're still doing things in batch for the most part. Transactional, you're looking at more or less a unique index. In an analytical system, you're going to have multiple indexes on a table possibly. Again, you're looking at detailed data versus detail and aggregated data in an analytical system. As far as I/O and memory, the transactional is going to have lower. Now, you'll still have probably quite a bit of writing going on, but on the analytical side, if you're comparing the two, you're going to have higher. And lastly, the transactional database, the response time does not depend on the database size. But analytical, it definitely does. You have a lot more data, and you're pulling out so much more of it that it really depends on the database size. So in summary, the benefits of a data warehouse for those end users is the data is presented in a structure that's easier for them to use. They don't have to know all the different tables to join to get to the data from your transactional system because you've normalized everything, and they don't have to pull it from multiple sources either. Self-service BI is a very, very big advantage of this. Excel is a beast, and a lot of users prefer it over other tools. It can provide a lot of insight into data analysis if used correctly. The data warehouse allows users to get to the data without necessarily needing IT. Queries run faster, but on the same side of that, they don't interfere with your production transactional systems because you're running from a completely separate environment or database. The data is cleaned and it's a better quality, and you do have that historical data available. All right, so far we've taken a look at what the database is used for, but another key element is getting the data to the users quickly, and this is where a good indexing strategy comes into play. So what is an index? It's really a vehicle for accessing your data faster, hopefully. It's a way to speed up searching for your data in a database, which can help performance, sometimes good and sometimes bad. If you're overdoing your indexes, your performance won't necessarily have a very good impact. You do have to be careful with which ones are appropriate and which ones are just not used anymore. It should be able to operate with other indexes to filter out the records before accessing the raw data. You want to use an index as much as appropriate to not touch the raw data, but that doesn't mean you shouldn't touch the raw data. It just means that you should get to it as quickly as possible, and the index should be as small as possible and utilize your space efficiently. All right, so the ultimate goal of an index is to reduce the number of hops it takes to bring back your results as quickly as possible. Hence the frogs.
Yeah, I love your frogs. I have a question for you. In your data warehouse, do you have tables without indexes to help optimize your loading process?
Yes, yes, and actually I do talk about that in the further down. We're going to talk about dimension tables and facts, and then the staging tables as well. So
okay,
yes,
great.
we do. Yeah. All right, so indexes don't actually affect the data returned. The same results are returned regardless of the indexes. But with your indexes, the query response time is faster. However, you do have to realize loading data is slower, although I have a tip for that later. And then the SQL engine actually uses more seeks with an index and more scans without an index. And since index, you're actually storing data as well, you'll need more storage. Now, everything I'm about to discuss, again, we're going to talk about dimension tables, what they are, and possible ways of indexing them, fact tables, both summary and detail, and then the staging tables, like he was mentioning. So with all of this, there are no hard and fast rules, because when to use an index really depends on how the data is retrieved by queries, and like most things in SQL Server, it truly depends on your environment. All right, dimension tables. In a data warehouse, these are descriptive attributes or fields. They're much more text or string-based, and they're more of a lookup value. Examples of this is your product name or your color. Your product ID may be used in your, let's say you sell different products. In your orders table, you're going to reference your product ID, much like the transactional system would, so you don't have to repeat data. In a data warehouse, of course, you are going to repeat some data, but in some cases, if you have a dimension table, you don't have to repeat a whole lot of it. Your product classification or group, customer name and address, again, you're going to use your customer ID, so the table that stores the name and address is your dimension table. And then all the dates, the hierarchy. So if you have a date and you know which week it belongs to, which month it belongs to, which quarter it belongs to, which year it belongs to, things like that, all of that hierarchy, those are dimensions. All right, for these dimension tables, indexing them, there are debates on which way you can go, which basically means that what works best for your environment. Some say that normally when you have you're pulling from different sources, they each have their own natural business key. So you could have an ID that references this is coming from source A and this is coming from source B, and then use that natural business key along with that source ID. Or you can have a unique key on that table and use that as your clustered primary key. Also, you're going to have non-clustered indexes on the foreign keys as well. Normally, you're going to have a single index for each. That way it can reference those other tables very quickly. In his book, The Data Warehouse ETL Toolkit, Ralph Kimball actually discusses the use of the SaraKit key within the ETL process. And if you do have it, it's actually recommended that you use that in all of the other tables. Rather than the source ID and that natural business key, you're going to kind of use that unique surrogate key. The biggest thing for this is finding out which indexes on those foreign keys are appropriate, not just putting them on everything. All right, so those are the lookup tables. Now we're looking at the fact tables. These are measurable units or metrics of the dimensions. And they can be detail or summary. So examples of that would be your, for this product ID, what's the count that this customer has ordered or on this date or for this state, that type of thing. The count of products sold by a supplier or date or state. Also, to kind of go in a totally different direction, the count of number of disasters by type, so number of hurricanes or number of earthquakes, that type of thing, by date, by country, by state, what have you. So really you're being able to measure a number in most cases. It's not all cases, but for the most part it'll be a number. All right, so fact tables that are details. So if you have an order table, this is going to be a fact table. You're going to say what the order date was, which customer it went to, which product was ordered, that type of thing. So that's going to be a detailed fact table. In most cases, when you're indexing those, you're going to start with a date or the business key column, depending on how the data is queried. Most fact tables are going to have a date dimension because most analytics are for some kind of a time range of some kind. That's kind of a good place to start, kind of thing. So these fact detail tables, when you have your index, having included columns in your index are really good along with the date or the key. Now, I don't know much about partitioning, but I know I read about this quite a bit, so I kind of added it as a note. If a table is partitioned, adding a single column index on the date key on each partition. All right, so I have a couple of examples here. Now, I actually work for a company called LHC Group, and we do home health care. So nurses or therapists or doctors come out to the person's home because they're homebound. They actually can't go into the hospital or doctor's office very much. So in looking at our, now this is all just development data, but in looking at our visit table, it actually has just shy of 23 million records. If I just do a count with no indexes of any kind, it takes 30 seconds to do. Now this isn't really good, very used for analytical because no one's really going to want to count of just all visits, period. They're going to know basically which facility they came from. Maybe they were in Louisiana, maybe Alabama, California, that type of thing. But it does give about 29 seconds to run that. And then I also ran, again, something a little bit more useful for each facility, for each patient, how many visits did we do? And that took me 31 seconds to run, and that was just shy of 450,000 rows. Now, all I did was add a non-clustered index on the source ID and the natural business key, the visit ID. And this, again, the source ID kind of tells me it came from this vendor versus that vendor kind of thing. And so my 23 million records, rather than 29 seconds, it's 5 seconds. Quite a bit of a difference there. And then when I'm grouping that by facility and by patient, like I did before, rather than 31 seconds, I've got 13 seconds. And again, I mentioned that the indexes do not affect the number of records returned or the records themselves. So I had the same number of records and I had the same exact data set each time. All right, so now we did talk about the detail fact tables. Now there's also fact tables that are summary tables. Just like the detail tables, you're going to start with the date column. Now with the detail tables, you could start with that natural business key, but on a summary level, you're basically looking at a date to start with. A lot of times you're going to have an index with a date column and then one aggregated column. So let me give you an example of what this fact summary table looks like. So again, we do home health, so we admit patients, we visit patients, and we discharge them when they're better. So if I have one table that is a summary that says for this facility and this date, I have this number of admits, this number of visits, and this number of discharges. My ETL process is actually what creates that summary table. And so I would actually have an index in some cases. Again, this really depends on your environment. But I'd have an index on the date and the number of admits. And then another one on the date and the number of visits. And then again, another one on the date and the discharges. Now, as much as I say that, not all of those aggregated columns need an index. But the ones that are really queried quite a bit, and this is really where digging into the query plan cache and things like that can help you determine which ones are used and which one the indexes are really going to be helpful for. The reason I mention a difference between the detail fact tables and the summary the summary fact tables is that these summary tables will be queried differently than the detail tables. Another note about this is not all warehouses have fact summary tables. I know at LHC we use a product called MicroStrategy as our analysis software, and it's smart enough to know, based on what the user has dragged onto their report, to know which is the fastest table to get data from. So summary tables help a lot. So if a user comes in and says, I want to see the number of admits for our Louisiana facility for the month of March, it knows, since I have a month summary table, oh, that's my fastest route to get there, so I'm going to go ahead and grab that. Whereas if they drag on a date, it knows to go to my date summary table. And then if it drags on more of a detail level type of thing, so which insurance did they use, or some kind of notes for that admit, things like that, it knows not to go to one of the summary tables at all. It needs to go to the detail fact table. So it really kind of depends also on which software you use and how it interacts with the data warehouse. So I do have an example of that fact summary table. And again, so the number of referrals, the number of admits, and the number of discharges for each facility for each month. Now, this is with no indexes of any kind. In 8 seconds, I was able to pull data from 2004 all the way to now for every facility we have, and I know the number of referrals, admits, and discharges for each of those. So it really does help quite a bit. All right, so do we have any questions so far? Because I am going to get into the staging stuff, but I wanted to kind of, this is what the end user sees. Do we have any questions so far?
The only question we had was they wanted to see what you were doing, but you went right into it. So that was perfect timing.
All right.
So they can see your query here and how you were, pulling the data. I had a question, actually. Do you ever use computed fields in your data warehouse?
I do, mostly on the detail type of fact table, or maybe a dimension table, but much more of a detail level. And then if those computed columns need to be aggregated up, then it's just a sum or a count into my summary tables. I try not to do too many computed columns, at least for what we have. Mostly I'm kind of I'm keeping things very granular and then letting MicroStrategy handle more analysis on that kind of way. That way, if the user changes their mind, they're not waiting on the ETL to make a change because I did all that computation myself in the ETL. MicroStrategy can change their metrics because the data is broken out for them, and all they have to do is change the way that they're looking at it. Does that make sense?
Oh yeah, I just was wondering if you were ever leveraging the computed, fields in your warehouse, because that's something I never explored, but I always think about it at times whether I should do it. I kind of think how I can leverage that technology. So that's good to know. Thank you.
I think I leveraged that more when I was a developer than I did on the transactional side than I did on the warehouse. So.
Okay.
Yep. Yep. Okay. All right. So those are really what the end user sees. Again, they have dimension tables, which are more of your lookup values. And then you have fact tables, either detail or summary, and that is really what you're measuring. If you're creating a data warehouse, you're more than anything going to have an ETL process. And ETL stands for extract, transform, and load. And there are different iterations of that. You may do ELTL or ETLTL. There's a lot of different ways about doing it. But in a lot of cases, you're going to bring in data into a staging environment, manipulate it, transform it. That's my favorite part. That's where the magic happens. And then you can touch your data warehouse only when all of that is completed. That's how we do it here. So I actually have 3 different databases. I have a source raw data database that everything comes in raw. And then I move it into my staging database. Again, I'm bringing it in as raw, but I do map things like our facility IDs here, and rather than the source facility IDs and things and patient IDs, I kind of map some of those. But in general, it's all raw. And then I aggregate it, and I join everything and all that, and I make tables that have the same exact structure as what the warehouse does, and I get everything prepared. Everything is done. And then my last step of the entire ETL process is loading it into the warehouse, and that step is less than 15 minutes. So from a user's perspective, they only actually have any downtime while that's loading, which is less than 15 minutes. And that just depends on which table you're looking at. So when you're actually working in that staging area, and again, that's just one of the ways of doing it. There are multiple ways of loading your warehouse and getting things ready. But if you do have a staging environment, then those staging tables are going to be indexed differently, if indexed at all. One of the biggest things to think about is, will that data or that table be queried only once or multiple times during that ETL process? Basically, will it really save time to have an index on it? So let's consider this. You have a query that returns results in 2 minutes. If it takes 15 seconds to add that index, but it only saves you 50% of the time, you've only saved 1 minute. Does that really make it worth it? On the other hand, if that same table that you indexed, again, it takes 15 seconds to add that index to the table, but that table is used like 12 times throughout the ETL process. It may save you like 12 minutes right there, and that might be worth it. It really depends on your window of how long your ETL process can run. Sometimes that's over the whole entire night. Sometimes that's you have an hour. It really kind of depends on what your time limit is. Also think about, how is the data loaded? Is it truncated and then repopulated the entire table? Or is it updated? Things like that. Another thing to think about is, with these staging tables, if you're bringing them in raw from the source system, most of the time the transactional system handles those foreign key referential integrity indexes. You don't necessarily need to have that also on the warehouse side, because the transactional system handles that for you. It's not all cases, but in most cases, that's just going to slow things down for you. All right, and lastly, heaps are not so bad. A heap is when you don't have any kind of index on a table at all. And most people, when they think, oh, I need an index because this is running slow, well, not everything needs one. If you are using that table once and that is it, and you're not doing anything to it, you're not updating it, you're just grabbing the data as is, then having an index may actually slow you down. This really depends, again, on your environment. And the last thing I'll say about heaps really is, if you have a heap, it should be because you chose to have a heap. Heaps are really kind of the easiest thing to do. You just put a table out there, you put data in it, and that's it. And that's called a heap. But you really should think about how you're going to use that data to see if you need an index or not. And if you choose not to, then you've chosen to keep that as a heap. So that really should be the reason you have heaps, is because you chose to. All right, so most indexes, traditional indexes, are row-based. So you have a key, you have a row, things like that. In 2012, the column store index was introduced, and those are column-based. This came out specifically because of bulk data, or BI, or data warehousing needs. And then the one caveat is, in 2012, the column store index must be dropped or disabled in order to load the data into the table. In 2004, this no longer needs to be done, so they have made improvements there. All right, so the column store indexes, and this is directly from Microsoft TechNet. So the benefit of a column index is derived from the compression. So if you have a character or numeric column with large amounts of duplicated values, that's really where this comes into play. So let's think about that visit table. Again, a nurse or a therapist or a doctor has visited a patient. You're going to have a lot of different employees visiting on the same day. So that visit date is going to be duplicated in that table quite a bit. That's actually a really good candidate for a column store index. If I am looking at a unique value in most of the records, your column store index isn't really going to work as well as what you'd like. Other examples are sales regions or states, things like that. Again, a lot more repeated values in your table. All right, so which indexes should you have? This is a big, big question, and there's a lot of resources online for this, and in books. And this is a topic in and of itself. This can actually be probably 3 presentations long. But really, there are some tools, and I have 3 examples here for you that are really good at helping you define which indexes should be done. Of the indexes that you already have, are they being used or are they not? If they're not being used, it's just more space that you're taking up really kind of for nothing. The way that you're looking for those, for which indexes you want, are the same in a transactional system that they are in an analytical system. Nothing is different there. So there's a index maintenance script from Ola Hallengren. Brent Ozar actually has SP Blitz Index. And then there's a CodePlex index analysis project, and I think that's from Jason Straight, but I'm not 100% sure there. All of this will be available on my blog, and it is being recorded as well, so you'll be able to get to these links. I'm leaving it up here for a little while too, but you will be able to get to these links after the presentation.
So we do have one question here. Okay. I'm going to stop you right here for a second. Yep. The question was, how do you notify users when when the data warehouse is down, and I would guess when it comes back up?
Okay, well, this gets into your overall data warehouse strategy. So again, with the example that I gave, we have the staging environment, and then the data warehouse itself is only affected for the last 15 minutes of the full process. Therefore, our users are not really, and okay, let me back up a little bit too. Because I have tables that are in the exact same structure that the warehouse has, and I load everything into that, and then all I'm doing basically is making a copy from this into the warehouse. Everything is done, and if there's any failures, it normally fails before the warehouse is touched. Therefore, the users still have data. It may be 1 day old because the ETL may have failed, but they still are untouched. At that point, it really gets into, do you want to notify your users? Do you not? If you do, you can always just add an email to your job. You can automate that quite a bit. I know that there are some frameworks for ETL processes and things like that, and I know that that has some capabilities. I haven't researched a whole lot, but so there are tools that you can use out there, but it really depends on how your overall architecture is for your your strategy is for your warehouse. If your warehouse, if things fail and your warehouse end user tables are affected, then yes, your users will have to know. But if it fails way before that and your warehouse is not touched, they may not need to. So it kind of depends on how you're setting things up.
Okay, thank you.
Mm-hmm. Okay, so other index considerations. Check the query plans to see how the tables are being queried. This is a very big bullet, even though it sounds very simple. So in a transactional system, if you remember way back when, I had said that you have simple known queries. Your programmers write stored procedures or queries or code in their software, and it does the same thing with just different values, but it's using the same query each time. Whereas on the warehouse side, your users will change their minds. So I know every company I have worked for, the senior management says, this is very important, and they come down with a mandate that we have to make sure we improve such and such of a measure. Well, 2 weeks later, that's no longer important. This other measure is now important. So users will change their minds, and they will want the data presented to them in totally different ways. So on a warehouse, you really need to keep track of how your data is being retrieved so that your index strategies can adjust as necessary. Due to the fact that if you have an index, your data load time is slower, you can disable or drop those indexes before you do inserts or updates, and then just rebuild them afterwards. It's a helpful little thing there. One other note, if you disable your index rather than dropping it, the definition of your index is retained, and so are the statistics, which helps you determine if that index is being used and that kind of thing. Very, very, very helpful right there. When you're planning your index strategy, make sure you think about index maintenance. And then if a clustered primary key is used, and if you happen to truncate and reinsert all of your data, try to insert the data in the same way that the clustered index would do so that the pages fill up in sequence. That was something I ran across, and I was like, oh, that makes perfect sense. Never dawned on me before that. And then, again, just to repeat, monitor your index strategy, because the data warehouse is different from a transactional system in the fact that your users are going to request data in completely different ways than what you expect and what you know of they were doing before. I do have some resources, and I really wanted to kind of leave quite a bit of time for questions and answers, but I have some web links here as well as a couple books that are great for warehousing as well as indexing. And again, all of this is recorded, so you will be able to get to it afterwards through the virtual chapter event archive site or page within their site.
Right.
As well as on my blog.
We do have two more questions for you here.
Okay.
Let me see what they wrote. Basically, we're getting a question. Do you enforce foreign key constraints between fact and dimension tables?
The answer is as with always, it depends. But there are many, many times where I do. Most of the time, I'm using the dimension table to populate that detail table, so I know that it's already going to be there. Most of the time I go through my my dependencies first. So each source system, I kind of build my detail tables, my detail fact tables. So my order detail, things like that, based off of my source system, and then I actually make my lookup tables. And then when I'm actually making the final table that the end user will actually use, I'm joining those two together so that I know the data going into that final table has the transactional data, but also has that lookup data from the dimension table that I've already built. So I don't really have to use an index for that or a constraint for that due to the way that I'm actually making my query. Does that make sense?
Yeah, I'm with you. Could you go back one slide for a second? Thank you, because I have a request. They want to look at that slide for a minute.
Oh, yes, definitely.
Okay. And another question here we have, they're saying that they have users that want reports within 15 minutes. If they have a big ETL process, that's not acceptable. And they want to know, is there another way they could leverage a data warehouse because that's not, I guess, acceptable, for their case.
Okay. So a couple of things. First of all, I'm going to ask a question, and then you can answer while I'm answering something too. Are the reports running for 15 minutes, or are you updating your data warehouse during the day multiple times, and therefore it takes 15 minutes? Of course, you may have thought my 15 minutes, but so the users are being impacted by that 15 minutes.
Let me see. I got to expand.
So while you answer that, let me go ahead and answer a little bit differently. So our ETL process runs in the middle of the night. I think it starts at 1:45 in the morning. Now, the trade-off of this is I do have to wake up at 3 in the morning if it fails, but it finishes before 7 o'clock Central Time, or at least that's the goal. Sometimes it goes a little slow, but normally it's because of resources on the server. But knowing that it finishes before 7 o'clock, Eastern time zone as well as all the way through the day, the last data warehouse that the users use isn't touched. So it's basically the users are interrupted between 6:45 and 7 a.m. and they can run reports all day long, and they're not affected by anything else. And they have the most up-to-date data when they first arrive. If you run it multiple times during the day, normally you're going to segment that so that you are running one data mart at a time or one piece at a time. So that way you're not doing the entire thing, but you're updating small pieces of it in chunks. And that kind of keeps your operational data separate than your financial data, separate than your human resources data, and not everybody is affected multiple times during the day. Does that make sense?
Yeah. So he answered your question. He just said that the data needs to be data needs to be up to date within 15 minutes. So updating overnight is insufficient. So it sounds like, and I'm going to talk with you for a second. It sounds like it's almost like they need a mirror always on if they need data up to date that fast. But how would you think?
Yeah, that's exactly how I was going with that. So if you have an always-on type of resource, then you can use the copy to do your data warehouse stuff. So you could actually have your staging environment using, I don't know, maybe a change data capture or something like that, or use the mirror to pull every 15 minutes or something like that. Your staging can kind of do everything, and it can actually be running fairly, quite a bit, and then you just update the data warehouse and every 15 minutes or something like that. So your staging is taking up the resources, and it's actually constantly moving, but your data warehouse itself is only updated in spurts of 15 minutes or what have you. So I think you'll be able to do it very well. It's just a matter of really planning it well enough to where users will be impacted minimally. Now, there'll always be a small impact because once you're updating a table, you're locking that and their report is going to hold. Or what I find a lot of is if we run something in the middle of the day, their report is locking what the ETL is trying to do. So that's one of the reasons that we just switch to, in the middle of the night, but or I update once or twice during the day if I have to, because if they're running something large, and finance is horrible with this, they run something really, really, really big, and it takes them forever, and then they put it into Excel just to use a small bit of it. So we're trying to kind of train our users to use the analytical software better, so they're not having to report or pull down all this much data. Once they have gotten to where they're not pulling that much of a data, it'll be easier for me to update the warehouse more often because they're not going to lock me nearly as much as they already are. So it's not always just loading your warehouse, it's also worrying about what the users are doing in order to be able to update your warehouse as well.
Okay, thank you. He goes, Mark is asking a follow-up here about snapshot. Have you used snapshot isolation basically to help with the locking issue? I know I've used it and it's helped where I work. We use it, the snapshot isolation for locking. Have you used it?
I really haven't had a need to, so I haven't. I know I have used with no lock on several things because once the data is loaded, it's not being changed. So with no locks helped my performance quite a bit. But no, I haven't used snapshot isolation.
Okay.
But I haven't had a need to, so.
Yeah, we did where I worked, and we implemented it, and we had a lot of locking going on, and it really did help with the locking issues. But it was more of a transactional issue than a warehouse issue.
Right.
So I really can't speak for the warehouse from where I'm at. Okay. Here's another question. They really like your frogs, they're saying.
Oh.
And they didn't know where you got the frogs.
I will put that on my blog. I'll zip them all up for you if you want.
Okay, great.
Because I just Googled them and I just grabbed them from a whole lot of different places, but I will zip them up and stick them on my blog.
Okay, here's someone, Ken. He's writing. He says he uses database snapshots for the data warehouse, and then
Mm-hmm.
all the reports are against the snapshot. And let's see, all the reports here. And then they update the database overnight and drop and recreate the snapshot. Downtime is just a couple of seconds. And
When
go
One
ahead.
really, really cool thing that I did with snapshots in my last job was we needed data up to date every hour. Well, while the database was large enough that while the snapshot was creating, reports couldn't be run off of them. So we made two snapshots, one that was updated every even hour and then one that was updated every odd hour. And then we actually used synonyms to, once the snapshot was done, it ran the synonyms job, and the synonyms went in and it knew if it was an odd hour, I need to point to this, the odd hour snapshot. If it's an even hour, I need to point to the even hour snapshot. Therefore, user reports worked continually, and it was minimal time for this synonym job to finish. But that way, we actually were able to leverage the snapshots, even though the database itself was very large and took a little while to do. So I loved it. It was a great little project.
We actually use snapshots too all the time on our mirror, and we snapshot it once a day, early in the morning, and that's like a point in time reference. So everything is frozen, and then the next day, so that's consistency. They can run their reports anytime during the day, and they get the same results.
Exactly,
And then we also
yeah.
have live data. So they're really a great tool to leverage. And one thing we were experimenting with the Always On was you can actually have a reporting copy of Always On and run a snapshot. So if they want a point-in-time snap of the reporting copy, they can hit the snapshot instead of the live data, which was kind of neat. So
Yes.
let's see.
Yeah, it's really great that Always On, because you can back up from the copy. You can, like you said, snapshot from the copy. You can mirror from the copy. There's a lot of things you can do from that copy. So
yeah, there's a lot of options that you can leverage when you're implementing Always On. You're exactly right. Let's see. I'm getting lots of questions. Let me. If I missed your question, just FYI, I'm going to save all the questions and email them to Glenda, and I'm sure she'll be glad to respond to y'all. So let's see. Here's a question about snapshot isolation. They're mentioning that it introduces some fragmentation, quite a bit, according. I'm not sure. We have just an index, maintenance program that handles that. Do you happen to know, Glenda?
I don't. That's actually one of the reasons I haven't used it, because I haven't. Well, again, I haven't had a real need for it, but it introduced just enough that I didn't even want to go in that route. So
okay, sure.
No.
The next question is, what type of ETL tool are you using?
We use SSIS. We looked at a few others, but really SSIS gave us everything we're looking for. I will tell you, if you use SSIS, you really need BIDS Helper. So I would be lost without it.
All right.
Now, I will say in SSIS, I do leverage both the SQL execute SQL task, where sometimes my package is just a SQL task. That way, all of my packages, everything is consistently a package, even though I'm leveraging the SQL engine rather than the memory of SSIS. So just because I say I use SSIS doesn't mean everything runs in memory from SSIS. There are a lot of cases where I'm actually using the SQL engine as well.
Okay. How many dimensions do you build in your data warehouse? And then i.e. mean index fragmentation, which obviously has a direct impact on index maintenance. Oh, I jumped the question. I'm sorry. So the question is, how many dimensions do you use in your data warehouse?
We actually have quite a few, but at the same time, not very much. So, okay, so again, we're home health. So we have like an admit detail table. We've got a discharge detail, referrals, visits, things like that. So most of all of that is in those detail tables. Insurance information, all of the patient data is in a lookup table, is in a dimension table. See, insurance data is basically in the detail tables. I'm trying to think of how many we actually use. So employee data, patient data, not much insurance. I'm really trying to think of everything we use those lookup tables for. And those are the two biggest ones. We have some with this kind of status, you know, so I have a lookup table for that, things like that. So I have some one-offs, but I don't really have a whole lot. We do have a lot in our detail tables so that the users can, well, we use MicroStrategy a lot more on the analytical side for computations and aggregates that are outside the scope of the summary tables we already have. So we put things a lot more flatter than we really kind of had to, just because it helps self-service BI for the users and all of that. So we don't have a lot, but normally they're kind of bigger tables, like I said, employee data or patient data type of thing.
Okay, thank you. We have one other one here. It's actually, yes, they're asking two more questions, and they're asking
Okay.
if you can explain a little bit more about the snapshot and the Cinnamon solution to make the always available data for users.
Okay. I will make sure I write a blog post about this as well.
Okay.
But basically, there's two snapshots. Now, this was before Always On, so you know, it would probably change because of Always On now. But basically, you'd have two snapshots. One is updated on the even hour throughout the day, and one that's updated on the odd hour throughout the day. Again, the reason for that is the database itself was too large to do a snapshot in an amount of time that it took like just under 10 minutes, which isn't very long, but if someone's running a report, that report would completely bomb out. So one even, one odd, and then the synonyms actually were updated to point to the snapshot that had just been done. So let's just say it's 2 o'clock. The even snapshot runs, and at 2:10, 2:09, whatever, the synonym job runs and then updates all those synonyms to point to the even hour snapshot.
Oh,
At
wow.
3 o'clock, the odd hour snapshot runs. The synonyms at that point are still pointing to the even one. But at 3:09, whatever, you know, whenever that snapshot is done, the synonyms are updated to point to the odd hour snapshot. So that synonym job was, I mean, so fast you couldn't even blink that fast. But only the first like 10 minutes of every hour, it was still pointing to the old snapshot. Otherwise, the users had data every hour that was updated. So.
Well, that's really cool. I mean, that's really neat.
Yeah.
I'm going to take one more question, and then we're going to wrap it up for today. And I'm going to forward all these questions to Glenda. So if we do miss a question, you know, we're going to go ahead and I'll try and get you an answer. And
Perfect.
so here's the question. Let's see. Have you built any cubes for like an accounting team to access the data easily with multiple dimensions of the data? So are you doing anything with cubes?
I'm not. In fact, this I do have my my slide up for this stuff, but we have a speaker coming in this month. Sorry, May 27th, and Tom LeBlanc. He's the Smiling DBA. If you want to follow him on Twitter or things like that, he is doing a presentation actually this Saturday for the Houston SQL Saturday, and it's on SSAS. So we've invited him to speak just so that I can learn SSAS. So if you check out, I know he has a blog. He probably has his presentation up. I'll see if we can record it too, so you can kind of check out later this month and see if we have it as well. But there are a lot of different resources online that you can check out talking about SSAS. I only know Tom. I don't really know many other people. And again, his name is Tom LeBlanc, and it's the Smiling DBA. I'm sure he can point you to other resources as well. I don't use SSAS. I think we're going to start doing that, but I am nowhere near able to do that. So
Okay.
I think my last SSAS class was on SQL 2000, and that was way too many years ago that I want to admit. So.
Well, that's all right. All right. Well, thank you, Glenda. It was
Thank
great
you.
having you today. And if anyone would love to go to a brand new SQL Server chapter in Acadiana, it's great. I've been there, and we're going to have all the recording on our website, and I'm going to put the date of her next SQL Server user group up there. And I just want to thank everyone for attending today, and I hope everybody has a great afternoon. Thank you again, Glenda.
Thank you.
Okay, y'all have a great evening. Bye.
Bye.